A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we are going to discuss about when and how to conduct a one sample t-test in SPSS. In my previous video, I showed you how to conduct independent samples t-test wherein we try to compare the mean of two groups and assess whether there is a significant difference between the mean of those two groups. In one sample t-test, we don't have the groups, but we just have one dependent variable which is measured on a continuous scale. That is, the data should be on interval or ratio level. So let us see when to use a one sample t-test and what does it tell us. T-tests are utilized especially when dealing with small samples, that is less than 30 sample size, and when the population variance is unknown. Whereas Z-tests are utilized when samples are large, that is more than 30, and the population variance is known. Although there is no direct way to assess the Z-test in SPSS, but there is a way to assess the Z-test through a syntax in SPSS, which I'll be showing to you in the upcoming videos. The focus of this video remains on how to do a one sample t-test. Usage of a t-test. T-test is a statistical test used to assess whether there is a significant difference between the means of two groups. That was independent samples t-test, which I showed you in the previous video, or it could be between a sample mean and a population mean, that is one sample t-test. There is one more kind of a t-test which is paired sample t-test, in which you take the readings from the same sample at two different points of time. Say for an instance before the treatment and after the treatment was given. So you are comparing whether there was a difference in the mean score of the group before the treatment or after the treatment. That is known as paired sample t-test. In one sample t-test, generally the null hypothesis is a statement of no effect, difference or relationship. It depicts the present understanding. What is an alternate hypothesis? A statement that contradicts the null hypothesis. It depicts the novel understanding that a researcher wants to confirm. Assumptions of a one sample t-test. Data should be measured on a continuous scale, interval or ratio. It should exhibit normality. That is crucial in case of small sample size, but in case the sample size is big, t-test is robust to the violations of normality. Small sample size, as prescribed by t-test, it works well on some small sample size. Population's mean is known, but the standard deviation is unknown. Let us check out an example and I'll show you how to do this in SPSS practically. The problem here is we want to check whether the average score of students belonging to a particular school in a competitive exam equals the average score of the entire population of students who appeared for that exam. Given that the population mean is 68 out of an exam of 100 marks. So we already know that the population mean, the average score of all the students who appeared in for that national level competitive exam is 68 out of 100. Now, we want to check whether the average score of a particular school, the students who gave the exam from that school, their average is significantly different from the population mean or not. So that is why We have the null hypothesis over here. There is no significant difference in the average score of the students belonging to a particular school in a competitive exam and the average score of the entire population of students who appeared for that exam. The alternate would be there is a significant difference in the average score of the students belonging to a particular school in a competitive exam and the average score of the entire population of students who appeared for that exam. Now, how do we interpret these results? Let us first check out how to do this test in SPSS and then we'll come back to this slide of result interpretation. These are the case IDs. These are the gender. One stands for male, two stands for female. We don't have to use this gender, which is a categorical variable. We use this in case of an independent sample t-test wherein we had two different groups and we wanted to compare their mean score, whether there was a significant difference between males and females mean score. For the purpose of one sample t-test, we just have one dependent variable, that is the marks scored by the students on a continuous scale. So you see here, these are at a ratio level 72, 65, 74.6. These marks are out of 100. And we have 50 cases with us. You see here, we have 50 cases with us, case ID 50. So we are not going to use the gender for the purpose of one sample t-test. We just have these marks and we want to know whether these marks are different from the population mean, which was 68, or there is no significant difference between the average marks scored by the students of a particular school, these 50 students of a particular school, and the national average of all the participants in that exam, that was 68. So how to find it? First, let us check the assumptions. I'll go to analyze, descriptive statistics, and explore. I want to find out whether this variable marks is normally distributed or not. I go to statistics, descriptives, okay. Plots, I check on histogram and normality plots with test. I have to uncheck stem and leaf. I click continue and click OK. Now you see here in the first column, I got the case processing summary. I have 50 valid cases. There are no missing cases. This is the information I get from case processing summary. Next is descriptives, wherein I get the mean and the standard error. So you see here, the mean score is 67.35 and the mean score of the population which is given to us is 68. So it seems that they are quite close to each other. So there shouldn't be any statistical significant difference between the marks scored by the students of the school and the marks scored by the participants on the national level, the average marks of the participants on the national level. First, we want to check skewness and kurtosis. Absolute value of skewness is 0.123. Kurtosis is minus 0.257. So there is a big amount of literature on assessing the normality values, and I have a video in my playlist. You might like to go back to check out that video wherein I have explained few methods on how to check the normality of your data. In case you want to check a univariate normality or a multivariate normality, then again I have a video in my playlist. So here we'll use that method which says that skewness has to be between -2 to +2. It has to be as close to 0 as possible. So in this case, I would say skewness is 0.123, which is very close to 0, and it is within the limits of -2 to +2. Kurtosis, it has to be within the limits of -3 to +3. Again, it is quite close to 0, -0.257. So I can say, yes, the dependent variable, that is marks scored by the students in this case, follows a normal distribution. I can assume normality in this case. I can even check it through the Kolmogorov-Smirnov test or the Shapiro-Wilk test. Shapiro-Wilk test is generally prescribed for sample size less than 50, and Kolmogorov-Smirnov is prescribed if the sample size is greater than 50. So I see again it is insignificant. The KS test tells me the p-value is insignificant. That means I cannot reject the null hypothesis. The null hypothesis for test of normality is that the distribution is normally distributed. In case this p-value was lesser than 0.05, then I would say that the null hypothesis is rejected because the p-value is significant, and therefore my distribution does not exhibit normality. So we can check it through test of normality as well, which is showing us that the distribution is quite normal. We go to the histogram to visually assess the normality. Again, you see a bell-shaped curve over here, which signifies normal nature of my data. QQ plot, you see all the points lying on this diagonal. So that's again signifies that my distribution is normal. We check for outliers. So you go to the box plot. Any points lying beyond these whiskers, upper whisker and below whisker, are deemed to be outliers. So in this case, there are no upper outliers above the upper whisker, no outliers below the lower whisker. So I've cleared the assumptions that my data is normally distributed and there are no outliers in my data. Now I can go to check on whether this mean value, which is 67.35, is significantly different from the population mean or not. For that purpose, I'll do a one sample t-test. I'll go back to the data sheet. I'll go to analyze, compare means. You see here one sample t-test. I click on one sample t-test. I take the marks in the test variable, and in the test value I have to put that average which I already have, the population mean, that is 68. I go to options, nothing has to be changed over here. Confidence interval percentage has to be 95%. Click continue and click OK. So now you see here the mean in case of my sample, which is 50, is 65.35. Standard deviation is 7.37. One sample t-test. So you see here the value of t is minus 0.623. Degrees of freedom is 49. That is n minus 1. And is the total sample size minus 1. 50 minus 1 is 49. Significance level is 0.536. That means it is insignificant. Had it been below 0.05, I would say it is significant. So in this case, I failed to reject the null hypothesis, and the null hypothesis is that there is no difference in the mean value of my sample and the population's mean. So I failed to reject the null hypothesis and I interpret that yes, there is no difference. And when I look at 95% confidence interval also, I'll see the lower limit minus 2.7, upper is 1.4. That means 0 is lying somewhere in between the lower and upper limit. That states, yes, it is insignificant. Had there been no 0 in between this, I would say it's a significant and I would reject the null hypothesis. But in this case, through the p-value as well as the confidence interval evaluation, I assess that my mean score of the sample and the mean score of the population does not have any statistical significant different. So this is how you interpret the result, whatever you got in from SPSS. A one sample t-test was conducted to assess whether the average score of students belonging to a particular school in a competitive exam equals the average score of the entire population of students who appeared for that exam. The descriptive statistics revealed dash as the average score of the sample, that was 67.35 in our case, and the standard deviation, whatever you got from the descriptive statistics, you can mention it over here. That is for the sample standard deviation. The results reveal no significant difference in the average score of students and the average score of the entire population, as the p-value was greater than 0.05, as we discussed in SPSS results. So this is how you write the results. T bracket degrees of freedom, which was 49 in this case, is equal to T score, whatever you got it from the one sample T test table, results table, comma, P greater than 0.05 in our case, and brackets closed. Then you write a statement, hence the average score of students belonging to a particular school is not significantly different from the average score of the entire population of students who appeared for that exam. This shows that the sample does represent the population. Therefore, we fail to reject the null hypothesis, and the null hypothesis in this case was there is no significant difference between the average score of the sample and the population average. So I hope you learned how to do one sample t-test and when to use this one sample t-test. These are some of the useful resources which you might go into and explore further about different kinds of t-tests. I hope the video was quite interesting and knowledgeable for you. Thanks for watching and keep watching for more.